Curious minds, welcome to ProjexCellence ProDigy, your one-stop solution for all your project management needs. I'm Govind, a certified PMP, and today we are simplifying some essential quality management concepts. We will talk about quality control and quality assurance. We will explore what cost of quality means and learn about useful tools like flowcharts, SIPOC model, and cause and effect diagram. These tools help improve processes, solve problems, and maintain high standard in any project. Whether you are working on a predictive project as construction site or agile project like developing software, these ideas are the key to project success. Let's get started. Quality assurance QA and quality control QC, these are two fundamental aspects of quality management. They are often used interchangeably, but they have distinct roles and functions. Let's understand these both terms with comparative analysis. Quality assurance, if we see the definition, so quality assurance is about preventing defects by focusing on proper processes and ensuring they are followed. While the quality control is about identifying and fixing the defects in the final product. Objective of quality assurance is to improve and stabilize processes so that defects are avoided. And objective of quality control is to find and correct the issues in the product before delivering it to the customer. Quality assurance focuses on processes and workflows to ensure efficiency and reliability. QC focuses on the product and deliverables. It checks for errors or defects. Activities. Under QA, we develop quality plans and policies. We conduct process audits. We train the team and develop them. And the activities under QC are inspecting and testing the products, reviewing and verifying deliverables, performing the quality checks. Come to the responsibility. So project management team, and if the organization has process improvement experts, so they are the responsible person for the QA. Come to the quality control. Project team members who are involved in testing or quality inspectors or quality control staff, they are responsible for QC. Quality assurance is a proactive process. It is ongoing throughout the project life cycle. And quality control is a reactive process which is performed after the product is developed. Let's try to understand these two terms with real world example. Suppose the QA team in a car manufacturer company, they will ensure the assembly line follows standard operating procedure, SOPs, and quality standards. So this might include regular audits, staff training, and process documentation to prevent assembly mistakes. While the QC team in the same car manufacturing company, the inspectors will check the assembled cars for the defects like misalignment of doors or faulty electrical system or paint imperfections. So the issues will be found and are fixed before the delivery. Cost of quality, COQ. It is defined as the total cost incurred to ensure that a product or service meets quality standards and the cost that result when it fails to meet these standards. So what it means? It means it is the total money spent to prevent mistakes, ensure good quality and fix problems when things go wrong. So there are two types of costs involved: cost of conformance and cost of non-conformance. So cost of conformance refers to the money spent to ensure product or services meet the quality standards. So There are again two kind of cost here, prevention cost and appraisal cost. So prevention cost is, we can say, quality assurance. So these are incurred to prevent defects from occurring in the first place. So what we do? We do the training, educating employees on quality processes and standards, process improvement, upgrading equipment or methods to improve the product quality, and quality planning, developing a detailed quality management plan. And what comes under appraisal cost? This is the quality control, QC. We discussed it in last slide. So these involve expenses related to evaluating product and processes to ensure quality. So like inspection, examining products during various stages of production, testing, conducting the test to validate that the product meets specification, and the quality audits means regular checks to ensure processes are done correctly. Second is the cost of non-conformance. So these are the costs that arise when products or services fail to meet quality standards and which lead to failures that need to be rectified. So this is the cost a company has to bear when something goes wrong and the product or services doesn't meet the quality standards. So these costs occur because of mistakes, defects or failures. These could be again two types, internal failures and external failure cost. So internal failure cost, this happens when defects are caught during the production, but fixing them still costs the money. And external cost, these are the much bigger problems because they affect customers directly. Company has to face warranty claims, product recalls or loss of reputation. Let me share you one real life example of COQ. In 2010, Toyota faced a massive issue with sticky accelerator pedals that could cause unintended accelerations. So this problem led to a global recall of over 9 million vehicles. So we all know Toyota is a big auto giant and the quality they maintain is of highest level, and still the issue happened. So before the issue arose, Toyota already had prevention and appraisal measures in place to ensure the product quality. When the defect slipped through, Toyota incurred significant non-conformance cost. This one, non-conformance cost. It escalated to external failure cost here. So they had to recall 9 million cars, spending billions on repairs to fix the sticky accelerator pedal. And some more, Toyota's image as a quality focused brand was hurt, which lost customer trust and reduced their sales. Next topic is quality tools. So flowcharts. Among all, flowcharts are the most popular tool used in the quality management. These are diagrams or graphical representations that show how a process works step by step. These charts use symbols like arrows, ovals, rectangles, and diamonds to represent the actions, decisions, inputs, and outputs. In quality management, flowcharts are very helpful tools for understanding, analyzing, and improving the processes to meet the quality standards. If we see here the key components of flowcharts, so start and end is always shown with the oval symbol, start, end, project completion, and process, actions or activities are shown with the rectangle. We can see here all the rectangles, these are activities. Decision points, so either no or yes, so we show them with diamond, and arrows show the flow of process and direction from one step to another. If we see this process diagram here, so the topic of project is technological development. The project will start, so the objective will be defined and the requirements will be analyzed for this project. If requirements are approved, so we can go ahead, yes, then we can go ahead with this project. If requirements are beyond control, no, requirements are not approved, so we will end this project here. So no need to go further, no need to invest energy and money on this project. So then next step, similarly, we go for the project, then design solution, we develop the prototype. If prototype is approved, yes, by the end user, client, then develop the product. If no, then again you review the design. Then next step here, you develop the product, so you have to do the testing and debugging. And if it is successful test, yes, then refine the product, evaluate result, and project will be completed. If the testing it got failed, so then again you have to come to this point. So how these flowcharts help in quality management? Visual clarity. Flowcharts simplify complicated process into easy to flow steps we saw here, which helps team to understand and follow them. Identifying inefficiencies means finding weak points. So flowcharts make easier to identify unnecessary steps or inefficiencies that can be removed to improve the process. Standardization or consistency. Flowcharts ensure that everyone has clarity and performs the process the same way, no matter the different team or working in shifts. Training and communication. They are great tools for teaching new employees and explaining standard procedures clearly. Problem solving. Flowcharts help locate where problems or errors occur, which make it easier to find and fix the root cause. Next popular quality tool is SIPOC model, SIPOC. This is a simple tool which is used in project quality management to understand and improve the processes. SIPOC stands for suppliers, inputs, process, outputs, and customers. It helps map out a process by showing where materials or information come from, how they are used, and who receives the final result. This structured approach is especially useful in the early stages of improving processes or managing quality. Components of SIPOC. So suppliers, these are the entities or individuals providing the inputs needed for the process, like vendors or manufacturer. Inputs, resources required for the process to function, like raw material, data, labor. Process, the series of activities or steps that transform inputs into outputs. And outputs is the final product, services, or result delivered by the process. And customers is the end user, client, or stakeholders who receive and utilize the output. So these are the components of SIPOC. So what is the usage of SIPOC in project quality management? Initial project planning. SIPOC is often used at the beginning of a project to map out the high-level process and identify the key elements. Process improvement initiatives. It is used in Six Sigma and other quality improvement methodologies to identify and analyze process inefficiencies. Training and onboarding. SIPOC diagrams can be used to train new employees and onboard team members by providing a clear overview of the process. Quality audits. During quality audits, SIPOC helps in understanding the process flow and identifying areas where quality checks are needed. So let's understand the SIPOC model with one real life example. Installation and commissioning of a 20 megawatt solar power plant project. So here we have suppliers. Who could be the supplier in this project? Solar panel manufacturer, cable suppliers, inverter providers, and EPC contractors. Inputs. So what could be the input? Solar panels, inverter, labor, machinery. project design and land. Process, design, procurement, installation, testing, and commissioning. And output will be the functional solar power plant, energy generation report. And customers is the project owner, energy utility companies, or local community. So, here the requirement list. What is this? The requirement list specifies what is expected at each stages of the process, particularly regarding the inputs, outputs, and processes. So it serves as a clear guide to ensure all stakeholders, whether suppliers, process owners, and customers, to understand the expectations. So, like in our case, so input requirements. What could be the input requirements? So input requirements of the project could be that solar panels must meet some industry standards for the durability. And what could be the process requirements? Process requirements could be installation must follow the safety guidelines and project follow the milestones. What could be the output requirements? Output requirements are a fully operational solar power plant with a minimum efficiency of, let's say, 80 to 85%. Measurement list. Measurement list defines metrics or key performance indicators, KPIs, used to evaluate the quality, efficiency, and effectiveness of the process and its output. So in our case, so input measurement could be inspect the solar panels for less than 2% defect rate, let's say. Process measurement could be ensure 100% compliance with project schedule and safety standards. So output measurement could be verify the plant produces 20 megawatt plus minus 5% under standard testing conditions. And another thing we can see here, there are two feedback loops. So feedback loop in the SIPOC model represent the mechanism by which feedback is collected and used to refine the inputs, processes, and outputs. So in our case, input feedback could be customer identifies that solar panels are prone to micro cracks. So in this case, what will happen? Supplier provides the high grade panels. Process feedback could be the on-site engineer suggests improvements to cabling layout to be done to reduce the energy losses. So output feedback will be coming from the customer on delayed commissioning timelines leads to the better schedule planning. Another powerful and popular tool is the cause and effect diagram. The cause and effect diagram, which is also called the fishbone diagram or Ishikawa diagram, is a key tool in quality management. It is designed to visually map out potential causes of a specific problem or effect, which help teams to brainstorm, organize, and analyze the root causes systematically. It was originally developed by Kaoru Ishikawa. So this tool is widely used to identify and address issues effectively by dissecting them into categories. If we see here, this is the fishbone diagram. So the head represents the effect and the spine represents the causes. So head represent the problems or effect being analyzed. In our case, the poor project delivery quality. So this is the head. And spine, a central horizontal line pointing to the head of the fishbone, serve as the backbone of the diagram, this one. And bones, here we can see the bones. These are the major categories of causes branching off from the spine, like man, people, human related factors like skills, communication, or experience, machine, equipment, tools, technology, or equipment issues. So methods, so processes, so policies, procedures, or workflows, materials, raw material, software, or other resources, environment, external conditions like weather, market conditions, or regulations, measurement, data collection, or quality assurance practices. Sub-bones or sub-causes. These are the major categories of cause. These are the sub-causes of this problem. So what could be, like you see under equipment, we can see low maintenance of equipment could be one of the reason of this problem. Old technology, improper handling, or under management. Maybe the management has the low commitment to the quality. Similarly, for material, low quality of raw material, delay in arrival, people. So these all are the sub causes. In our project, let's say we have one problem. We got delay in a solar power plant delivery. So what could be the major categories and sub causes in this case? So major categories, man. So sub causes could be insufficient training for workers, poor communication among teams, and under machine category, maybe equipment breakdown or unavailability of the key tools. Methods, so inefficient scheduling practices or the lack of contingency plans. Materials, so there was a delay in the material delivery, the solar panels delivered late at site, substandard quality of solar panels. Environment, so adverse weather conditions, and the regulatory approvals took longer than expected. Next quality tool is control charts. So control charts, we call them as Sheward charts or process behavior charts. These are the statistical tools which are used to monitor and regulate a process over time. So they help evaluate whether a process is functioning consistently and stably, or if there are deviations that need to be addressed. So there are two terms in control charts. One is center line, CL, which represents the process mean or average, and an upper control line, UCL, and lower control line, LCL, which define the acceptable range of the variation. So we can see this control chart is monitoring the process output. It could be anything, any output, maybe the voltage, frequency, or anything. So the center line, the green dotted dashed line, this represents the process mean, which is calculated approximate 49.5, let's say. So this is the average value of the all data points and indicates the typical performance of the process. Upper control line here, the red dashed line above the mean. This is called UCL, which is calculated approximate 54.5. So this is the maximum value the process can reach before being considered out of control. Lower control line, LCL, the red dashed line below the mean is the LCL, which is calculated around 44.2 something. So this is the minimum value the process can reach before being considered out of control. Data points or the process outputs. The process outputs for 30 sample range between 44.2 to 54.5. So the value lies within the control limits from here to here, which shows the process is in control. So what are the advantages of control charts in quality management? Tracking process performance. Control charts provide a simple visual tool to monitor a process performance over time, so which allow managers to easily detect any deviation from the expected process outcomes. Identifying sources of variation. So by comparing data points with the control limits, the control chart helps differentiate between natural fluctuations and irregular variations that can be traced to specific issues. Supporting decision, facilitating decision making. The visual format of control chart simplifies the interpretation of data, enabling decision makers to quickly analyze trends and make the well-informed decision on necessary corrective actions or process improvements. Ensuring process stability. Control charts play a critical role in ensuring process consistency by flagging when the process falls outside the established control limits. It will prompt swift interventions to restore the process to its desired state. Enhancing quality. Ongoing process monitoring through control charts will lead to continuous quality improvement. So by identifying and addressing the issues promptly, they ensure that the final product or service consistently meets the quality standards and customer expectations. That's all for now. I hope you have enjoyed the content and the delivery. Let's take a short break and I'll return soon with more project management material. Before we part ways, I'd like to ask you to kindly show your support by liking and subscribing to my channel. Your engagement means a lot to me. Namaste, goodbye, Sampai Jumpa.